Hello guys, in this video we will be talking about caching for Pagination App. So we will be building application that will be providing some series of data for us, and it will support pagination like that, page and size. We will go from the beginning to the end and implementing it. What we will be paying attention to is how exactly to cache this solution, what kind of approaches we can take. For sure, we know that we will use so-called conditional HTTP requests, okay, and e-tag, and we'll be talking about how to use it. The way this video is made, I'll be going from the beginning, providing my analysis as if you were doing this. Also, I will use GPT for help. And I will use it as like a co-pilot, better Google thing, just to collect data and answer our questions that may arise. Sometimes we know that GPT provides contradictory answers, and we will deal with that, and I will show the examples. Why this video might be useful for you. First is just to go with analysis how to get this stuff implemented. Most likely we will use Scala language in the end, but in the beginning it doesn't matter. We'll be talking about HTTP, the architecture in general, the analysis, and the dialogue with GPT, and then we'll come to implementation. And the implementation, by the way, also will be provided by some insights for the implementation will be provided by GPT as well. At least we will try to use it as much as possible and see if it makes sense at some points. This is the first part of this video. There will be several parts for sure. We'll see how it goes and enjoy it. Thank you. We're gonna have a problem and the solution, hopefully. So let me just go quickly. We'll be working on the use case where the client will be connected to the server like that by HTTP API, HTTP REST API, and let's say it's going to be something like that. The API will be a series of some data with the query parameters page, let's say 1, and size, let's say 10. It's a classical pagination API, pagination, right? The client's gonna call a server. The client gonna call a server using this series API. Server will reply with the data, right? The server will keep some data in some database. Let's say database, doesn't matter what it is. It could be, let's say, Redis database. Also, the server could have, just to make it a little bit more complex right now, it could have a cache. So it's still kind of like a database, but it's in memory. Okay, so let's call it memcache. Why it's like that? Because this is quite common actually scenario, and it's going to be something like that. So if you're asking something in the cache, if it doesn't exist in the cache, it will go to database and fetch this data from there, put it to the cache, and then next time when you ask, it will fetch it from the cache. But in the cache, there will be some timeout, of course, for the data for these items. Let's call them items of the series of data. So it's basically it's a series of items. Okay, so I'll put this like that just to make it nice. Okay, since the documentation, put it like that as well, because this is documentation related to the client and the server. So that's what we're building. The thing is, there are some tricky stuff here. We'll be working on performance. Okay, so it's like a performance case, like in general, right? It's related to also pagination, right? And it's related to the cache. So we're gonna use a cache here to improve the performance of pagination solution, where we request some items in this series of items. Okay, and just to make it clear like that, and it's gonna be our title so we remember what we're doing. The problem is clear. Right now, let's talk about the solution. What is the challenge here? The challenge is, let's do some kind of like a use case. We'll go to email and then doing this like that. So this is our client. This is our server, and we'll see if there is some problem. Server, then the client calls the server like that with the REST API. And in this specific case, let's say series page 1, and exactly like that, size 10, right? And then it goes to database, right? Whether it's Redis or not Redis, maybe it's not that important right now, just to make sure that it's like a database or cache. Let's say in this case it's a cache, memcache. Yeah, so memcache and then the database. Basically, it's kind of the same what we just did here, but like a sequence diagram. Front, something like that. Just to make it visual, so we understand what's going on. This is database, this is memcache. The server returns something. What we need to do is to provide the cache solution properly. Yeah, let's just state the problem. Let's say we're fetching this page. Let's, in this case, it's a client 1 or client N, let's say, just to show that there could be many clients and they could be doing the same kind of requests. In this case, this client taking the request to get the data for the page 1, 10 items, right? The server receives this request by HTTP REST, and then it's looking for this request in the database, in the memcache. Let's say this memcache doesn't have this information because, well, we're just calling it first time. Calls database. Database has it, of course, and returns this data back. And this is filling the cache, so just getting this information back. And then this adds it to the cache, right? Like that. Yeah, like that. So it's returning back somewhere. Here we are. It's like doing this like get, and then it returns the item, and then this adds it to the cache, just adds it to the cache. Okay. In the end, it returns this item back to the caller, which is the server in this case, and it returns it back to the client in turn. You see, this is not just one item, there are many items. So basically, server receives the request and it's supposed to ask for each item in the memcache and returns back the request. So in the end, we receive 10 items. Okay, this is what we asked. So we asked 10 items, we're going to receive 10 items. We'll be getting back. It's going to be like that. And here we also will receive the item. So it could be something like, just to show it somehow that this is like a cycle. So theoretically it could be in a loop or something like that. There will be some kind of logic on the server side, okay, that will be responsible to fetch next item. Okay, I'll explain why. Because we cannot actually get everything at once without checking each item in the memcache. I'll explain why. So it returns back here. Okay, so this is like a kind of like a loop. Okay, a loop logic. And this loop logic or cycle or whatever you call it. Yeah, just to show that this is a kind of loop. So in the loop, it will fetch next items until 10 times it fetch 10 items. Then the client will receive something like that. I'll just showing it to you. So to make it absolutely clear, it's gonna be a JSON, let's say with 10 items in it. Array of items. Yeah, simplified version of this information, and usually has this color. Okay. So that's basically the data that we will be fetching from. So why this complication? Why the loop? Why is like that? So imagine we're asking for this client N, client 1, let's say, asking for first page. Okay, so it fetch it, blah, blah, and it put it back to the memcache. But in this memcache, like we said before, it will put it there, no problem, but it will put it there for some time. For some period of time because it's a memcache. So this item will be put there for, let's say, 1 minute or for 1 hour. Let's say for 1 hour. Okay, it's gonna be like that. Item 1, 1 hour. Item 2, 1 hour. Item 3. It could be not 1 hour for item 3. Why? Because let's say there is client N asked before for just for item 3. Okay, before like 30 minutes ago, and there is only 30 seconds left for this item to be in the cache. It used to be also like 1 hour, but right now there is only 30 seconds left, right? And let's say that item 4 is actually 1 second left, and item 5, it actually doesn't exist anymore. So it's already been removed out of cache because, well, because it's outdated, so it doesn't have this information in the cache, in the memcache anymore. So every time, next time when someone asks for item 5, it will need to go to database to fetch it, right? So item 5 is outdated. That's how it works, like in general. And then let's go and talk about the scenarios again. In general, we're talking about the performance, right? If client already has the data on its side, let's say it's asking for page 1, size 1, okay? So he only asking for the item 1 actually, right? And it's already in the cache. So what's gonna happen in this case? Because item is already here, what's gonna be reply back to the server? It's going to be something, not actually this JSON. It will return back like a status 334, okay, with empty body, let's say. So the point is that there will be nothing in the body, okay, empty. And status 304 not modified, okay. So not modified meaning that it's still in the cache, okay. So nothing has changed for this one. So I'm not going to return you this item 1 because you already have it. Okay, so that's a scenario. But let's say we ask not item 1, we ask for 10 items on the page 1. And this is our page 1, kind of, right? Until item 10, which like in this case, let's say 1 hour still. In this specific request, what should happen? We ask for page 1, 10 items. So it goes and checking on it in database. And it's not everything is perfect here, right? It's supposed to return item 1, item 2, item 3, kind of, right? Let's say this is like a second request. Okay, let's start again. Let's say we took a first request some time ago, and then we're doing another request, the same one. someone else doing the same request for 10 items on first page. But right now the situation has changed and we cannot simply return these 10 items to the client because some of this data is expired. Like for this item 1, it would return it 3 or 4, not modified. For this 2. But for that, for number 5, it needs to actually go to database, fetch it again, and fill the cache, and then return it back. Okay? Yeah. So there is a trick here. When client calls the server, it needs to provide some kind of information, kind of flag or something, right? That telling the server that we already have this data. Okay? It's supposed to be some kind of like a hash, let's say, like in the headers, basically. Pass some kind of value. Let's call it a token. Let's say 123. That telling the server that with this hash there is some association on the server side about the data we're asking, right? So in this case we're asking for 10 items on the page 1, and we're telling the server, we're asking it for this, and I already have the data about that. There is like a proof because this token 1 to 3 is association to this data, right? So please use this token and tell me whether my data is already outdated. If so, then return me back. If not, then return me 3 or 4. Right? And everything is fine about that. Is just in this specific case we're asking for 10 items, right? Do we think about this like a 10 items as a one resource, or we're thinking about this as 10 resources? Each item is a resource. So that's a question actually here to ask. But anyway, this is it token. So we're supposed to have this it token somewhere on the server side, right? Probably stored in the database, somehow associated with that. So every time when we ask for a token, the server goes and checking, is this token is already outdated? Whatever information associated with this token is outdated, then if it's outdated, then we'll go to database and fetch information back to the client. If not, then we will return 3 or 4, not modified, meaning that you already have it, no need to do anything about it. Okay, so this is the scenario that we're gonna talk and implement in here. Maybe I missed something like some concept. We will go and figure out the details, and then we will update this diagram to make sure that we understand what we're doing, right? But in this case, what we need to take into account is that we're talking about HTTP response status, not modified, and there is already something, you see, there is already something that we will use for sure. There are some specific flags designed specifically for that. It's called actually like conditional request, and there's specific headers if none match or if modified since, right? That client's gonna send to the server. So I said that we're going to have these headers, it tokens, okay? Yet, not it tokens, so I'm sorry. It's called a tag, right? It's called like it's a tag, okay? But for now, I'm just telling you that this is our problem that we're going to be talking about here, okay? Okay, thank you for listening for part 1. We'll meet you in part 2.